Hi guys, how are you? It's me again, Abdurrahman Abdul Qadir, student number STU 688888, and welcome to lesson 2, which we've already gone through yesterday. Lesson 2 of project management and risk, which is going to be in lesson 2 is project life cycle and methodologies. That's project life cycle and methodologies. Um, so I'm just going to start the lesson. So there's a figure 2.01 of project lifecycle and methodologies. So some text inside project lifecycle and methodologies, concept phase, knowledge, expertise of performing organization, agile phase, planning phase, agile pharmaceutical development, top down, closed phase, traditional methodology, agile, etc., etc., etc. So life project cycle and methodologies. Listen to the podcast, an introduction and overview of the project lifecycle and project methodologies to get you started on this lesson. You can also read the transcript of an introduction and overview of the project lifecycle and project methodologies. Learning outcomes. At the end of this lesson, you will be able to explain how project progress is monitored during execution, evaluate the role of change management in project delivery. So that's explain how project progress is monitored during execution, evaluate the role and change management in project delivery. So the learning outcomes at the end of this lesson, you will be able to distinguish project management and risk. Explore lesson 1. So I'm just gonna go back. Sorry, my page is acting up on me. Explore lesson 2. That's what we want. The project life cycle. The project life cycle refers to the collection of phases between the start and end of a project. The outputs from each phase feed into the next phase. The end of a phase is also marked by a management review, which serves as a checkpoint for whatever the project should proceed to the next phase. By dividing up the project in this way, with a major review at the end of each phase, management ensure they have good control of a project. Many trouble projects have failed because of a lack of management control. Concept, plan, execute, level of effort, percent completed, close. Project start and project end. This is figure 2.02, project life cycle. There is no one project life cycle adapted by all projects. However, they are similar and generally consist of four to five phases. Let's examine the phases next. Concept. The concept phase determines the mission, business needs for the project. Feasibility is also assessed on this. Is especially important in healthcare. As we have noted, healthcare projects that deliver patient care can involve a number of stakeholders. Patients have recipients, healthcare providers, insurance companies, and public sector organizations. As the number of stakeholder increases, complexity increases. This is because diverse stakeholder views have to be considered. Healthcare projects, in contrast to other projects, require more buy-in. This may not always be possible because of conflicting perspectives. Therefore, assessing visibility is particularly critical, and the result of this phase is a go-no-go decision on whether projects should proceed. This phase is also referred to as an initiation phase. Plan. During the plan phase, an outline design of product, service, the intended output of the project is established, cost and schedule are established. Then detailed planning is carried out. The main output of the build planning phase is the project plan. Execute. The execute phase implements the project plan. The actual work of the project is carried out. Monitoring performance is a critical function during the execute phase. Corrective action is taken when things deviate from the plan. Close. During the close phase, client acceptance of the project is obtained. Lessons learned are captured for reuse on future projects. Administrative procedures are concluded to shut down the project, and the project team is disbanded. Project methodologies. When each phase of the project life cycle is broken down further, it is referred to as the project methodology. The project methodology is the detailed approach to managing a specific project. Based on its characteristics in order to create the output of the project, the most common methodology is the traditional project methodology, a sequential top-down approach that details the generic project life cycle. It works well on projects with well-defined requirements and little uncertainty. On such projects, it is relatively straightforward to define project scope, schedule, and budget accurately at the outset. However, not all projects lend themselves to the traditional project methodology. Different projects have different characteristics, and the methodology chosen will depend on the particular project characteristics. The chosen methodology will define a set of repeatable procedures and techniques based on a common development philosophy. The methodology serves to guide the development of the project output, whether that be a product, service, or combination. Diversity in projects. Projects are diverse in their characteristics. A methodology that works well on one project may be disastrous on another. You may have come across a number of different methodologies already in your workplace. There is a vast array of project methodologies other than the traditional methodology. For example, rapid application development, rapid application development RAD, joint application development JAD, methodologies, and agile development methodology are all widely used, particularly on technology projects. Historically, on healthcare projects, the traditional project methodology has been used. However, this is changing as complexity grows and cross-functional input becomes increasingly important in healthcare. So methodologies such as Agile are now being used on process improvement projects also. Think about it. How then is project methodology selected? Feedback. Although in some cases the client, e.g. government, can stipulate that the performing organization use a certain project methodology, those often most often the performing organization chooses an appropriate methodology based on the project characteristics and its own experience. We shall look at project characteristics next, but it is important to highlight the importance of experience. Today, there are many methodologies that are available, and some can be quite complex unless the performing organization has project practitioners who are knowledgeable and experienced in a particular methodology. The methodology must not be undertaken. So, what project characteristics should a project manager or performing organization consider when choosing a methodology? One important characteristic is the nature of the requirements. Are they well defined? Are they continuous among stakeholders? Are they evolving? Think about it. For what reasons might requirements be ambiguous or involving? Feedback. There are many reasons. Here are just a few. The client may not be clear on the requirements. This is often the case with there are many reasons. Here are just a few. The client may not be clear on the requirements. This is often the case with cutting edge projects or projects that are implementing new business processes and is often true in healthcare. The wrong people may have been involved in the definition of original requirements. On many IT projects in healthcare, the mistake is made of involving just IT people in requirements definition. It is vital that end users are involved in user requirements. The end user must have the final say on the requirements. Users cannot envision the final deliverable and therefore cannot clearly articulate their requirements. This is often the case with projects that develop a service, e.g., online service in healthcare. Services are untangible, untangible and hard to envision. Many projects today in healthcare are complex and are and across a number of disciplines. It is often hard to identify the integral aspects of requirements. There are dependencies on new and emerging technologies, the implications of which are not well understood. There are dependencies on new standards. So the level of clarity in user requirements is an important characteristic, but there are a number of other important characteristics too that determine the choice of methodology. Let's examine these characteristics next. Sector and application area. The industry, business sector, and application area is an obvious consideration. Projects undertaken in construction, architecture, defense, space, software development, engineering, and manufacturing, IT systems integration, business process definition, pharmaceuticals, disaster recovery, e.g., Fukushima, earthquake, Tsumia disaster, California wildfires, Syriana refugee relief are all very different projects in certain disciplines have well-defined approaches, e.g., an architectural undertake an architectural undertaking. An architectural firm hired for a development project, e.g., to develop a shopping mall, will be involved in the developer's owner's definition phase. Then the design phase from conceptual development through a detailed definition and then implementation and closure. Projects in defense can be very prospective in approach and and have to comply with particular approaches and project standards. Similarly, for IT projects undertaken for the public sector, including healthcare, the government often stipulates the particular methodologies. Output of the project. The proposed output of the project will also determine the methodology. A methodology is used to develop a service A methodology used to develop a service would be very different to that for developing a product. Clarity in user requirements. Some projects have very clear and ambiguous requirements. When this is so, a structured and well-defined methodology, such as the traditional methodology, can be adapted, a process that goes through requirements, design, development, testing, and validation. However, the nature of other projects is that the requirements are fuzzy and ambiguous. Here it would be foolish to adapt a project methodology that systematically goes through a sequential phasing of requirements, definition, design, development, and validation. And validation. Risks. Many projects contain a high element of risk. These may include risks arising from proposed use of new or emerging technologies, or risks arising from evolving requirements or some external or environmental risk, e.g., dependency on a third party or government regulation. Again, such projects would need to manage risk by adapting a more iterative form of development, such as the agile methodology. The project often adapts a risk reduction phase to address the risk before committing to full methodology. The project often adapts a risk reduction phase to address the risk before committing to full implementation of the project. During the risk reduction phase, prototyping is often undertaken to assess and mitigate risk, and then to carry out more detailed planning when the risks have been assessed. Technology. The role of technology, especially new technologies, is a very important factor in many projects today. Whether project is a technology project or if the use of a new technologies is crucial to the success of the project, e.g. many public sector e-government projects such as the NHS Spine project. Methodologies based on incremental development and the progressive assembly of deliverables should be undertaken. This is because technology is rapidly changing and technology influences the way in which things can be done. Superior ways of doing things can result from emerging technologies. For this reason, a number of build cycles are appropriate with incremental goals. By incremental, by incremental is meant the process by which end user requirements are progressively satisfied. Timescales. The required timescales are also an important consideration. Most projects have more ambiguous timelines than the performing projects team would like. However, in some cases, the timelines can be very aggressive, perhaps due to a tight window of market opportunity, or because there is some regularity requirement that has to be fulfilled by an immovable date, or if the project is undertaken to address a crisis in an emergency situation. Often in such instances, deliverables cannot be delivered in a big bang fusion. They have to be released in a staggered fusion. Example methodologies, traditional sequential methodology. We shall now examine three diverse methodologies used in healthcare, starting with the traditional sequential methodology. The traditional sequential methodology is a detailing of the generic project lifecycle with its high level phases of concept, plan, execute, and close. It is the most straightforward of all methodologies as it is sequential in its approach. It is suitable on projects where the requirements are ambiguous and clearly understood. Concept, launch, and requirements gathering, outline design, detailed design, build, test, close. Figure 2.3 Traditional project methodology. When looking at the phase in the project lifecycle, we noted that the concept phase involves confirmation of business requirements and visibility, and that the close phase involves client acceptance of the project, conclusion of administrative procedures to shut down the project, and disbanding of the team. The other two stages, plan and execute, are taken down into additional phases, as shown in Figure 2.03. We give you an overview of these phases next, in the context of an IT project in healthcare. H launch and requirements gathering. Define requirement scope. Determine architectural option. Determine architectural options, e.g. interfaces between IT and business functions. Define detailed requirements. Plan early development. Build prototypes if applicable. Outline design. Define design of major project components, e.g. products, services, software components. Define architecture, interface between IT and business functions. Establish user interface design with user involvement. Define plans for testing project outputs. Design and build prototype if applicable. Detailed design. Review outline design. Refine and detail design and architecture. Develop test plan and test scenarios. Build phase. Build the system, e.g. code. Test software components. Testing phase. Integration testing. Perform acceptance tests. Confirm correct deployment. Obtain formal acceptance of system. Example methodologies, pharmaceuticals development. We now examine a very different methodology on another type of project. New drug development projects in the US. The project methodology is not dissimilar in the EU by pharmaceutical companies. We shall focus just on the high level phase of the methodology, discover and screening, per, uh, pereclinical development, registration workup, Post-submission activity. The methodology defines further subdivision, but this is too detailed for our purposes as it requires in-depth knowledge of the pharmaceutical sector and its development workflow. Discover and screening. Preclinical development, 10 plus years. Registration, post-submission activity, approval. Figure 2.04. An overview of the stages follows next. Project lifecycle and methodologies. Discover and screening. Basic and applied research and identification of candidates for pre- preclinical testing. Preclinical development, laboratory and animal testing to determine safety and efficiency, as well as preparation and filling of an investigation new drug IND application. Registrations workups includes clinical phases to check formulation stability, as well as preparation and filling of a new drug application NDA. Post-submission activity, work as required to support Food and Drug Administration review of the new drug application NDA. Example methodologies: Agile development. The Agile methodology is an iterative approach to project management, quite different to the other two methodologies examined. It is not sequential. It is now being adapted on some projects in healthcare. It is particularly suited to projects where there is ambiguity or uncertainty in requirements. A number of alternative solutions, innovation, or high risk technologies involved, or when a rapid turnaround of the solution is required. The Agile methodology recognizes that in these situations, it is impossible to plan, scope, schedule, and budget at the outset as one would do when adapting a traditional methodology. Kickoff, risk reduction, build cycle, deployment times n times 3. Figure 2.5 Agile approach. Agile incremental develops Agile incrementally develops the solution in a series of build cycles, often in conjunction with prototyping. It allows user requirements to be progressively satisfied with the frequent releases of incremental functionality. Within each incremental release, you may have a risk reduction stage to assess the impact of any high risk areas, e.g., technology. A number of build cycles, typically three, and a deployment stage. The build cycles serve as a feedback loop for the user to confirm the solution or suggest improvements. Now try this. Read your key textbook and find out more about agile methodologies. What are the advantages of using an agile methodology? Feedback. It is highly suited to environments where there is uncertainty and risk. The methodology promotes adaptive planning, evaluationary development, early delivery, and continuous improvement, and it encourages rapid and flexible reasons to change. One of the big advantages in healthcare is that it is user centric by releasing project outputs in an incremental fusion. Early user feedback is sought to adapt, improve, or even redesign solutions to achieve better project outcomes. Another advantage is speed. Project deliverables, even partially, can be obtained early because of the incremental delivery approach. As project managers, you need to be aware of incremental development methodologies such as Agile, but on this module, you are not expected to know the detailed methodology. It is increasingly used in healthcare on projects that push the boundaries in technology, e.g., medical device projects, but is also now being used in less glamorous areas such as process improvement projects in support of better clinical practices. Take this further. Can you identify some problems, risks associated with the agile methodology? Feedback. The methodology is fairly complex and should not be used on relatively simple projects where the requirements are clearly stated and technology is well known. Use on such Use on such clear out cut projects will lead to an inefficient development process. The methodology must also be tailored to the requirements of the particular project. For example, not all risky projects require a risk reduction stage in each release cycle. It may be that the first release cycle will reduce the risks adequately. Let's discuss. Read the following article about standardized methodologies. Settlement J 2017 Project Management help define and measure project quality. Settlement J 2017 Project Management help defining and measuring project quality. Using a standardized methodology to define project quality ensures deliverables fit customer specifications and receive high customer satisfaction when managing projects. Control engineering 5 P46 academic on file EBSCO host available at https://search.ebscohost.com/login/aspx direct equals true and dp equals edsgao and an equals edsgcl dot 4975082220 and sit. Last access on the 13th of July 2017. What are the benefits of using a standardized methodology in healthcare organization? Consider the benefits the paper highlights, but also other benefits that you can think of. Approximate word count 200 words. In your view, are there any drawbacks to deploying a standardized methodology throughout the organization? Explain why. Approximate word count 100 words. Post your findings on the discussion forum and learn from the responses of your colleagues. Respond to the response of one of your colleagues, offering your opinion. Agree respectfully, disagree, and or make suggestions. Project lifecycle and methodologies. From project methodologies to project process. Project management is a process-oriented discipline. Whatever the methodology, a project requires that certain project management processes are undertaken during the life cycle. The processes may not be undertaken sequentially, but they do not need to be undertaken. Project management processes fall into 5 categories: initiating process, planning process, executing process, controlling processes, initiating processes, planning processes, executing processes, controlling processes, and closing processes. You will note similarities in the names of these processes with the names of the phases in the generic project lifecycle, e.g., planning phase and planning processes. However, it could be a mistake to identify these processes solely with the corresponding lifecycle phases. For example, an element of planning will be carried out in the concept phase and in the build phase, although planning processes would be at their most intense during the planning. Level of effort. Initiating processes, concept, plan, planning processes, executing processes, controlling processes, and closing processes. Figure 2.06 Planning processes overlaid on project lifecycle. The remainder of the module will address the processes as they would be undertaken on a traditional project methodology. So, we shall look at the initiating processes in initiating projects, planning processes in planning projects, executing processes, and controlling processes in executing project monitoring and control, and closing processes in project acceptance and closing a project. Summary. In this lesson, we have examined the project life cycle, noting that project methodologies are the detailing of the project life cycle. We have compared and contrasted 3 methodologies used in healthcare. We have emphasized that the choice of project methodology should be determined by the characteristics of the project and the experience of the performing organization on the project methodology. The next few lessons will examine the high-level project management processes that must be undertaken, whatever the methodology. We shall start with the processes involved in initiating a project. The pages that follow will help you consolidate your learning in this lesson and provide you with an opportunity for reflection in moving forward. Take this further. Project methodologies generally provide go no go management checkpoints at the end of each phase. This gives management control of the project, enabling trouble projects to be spotted early whilst there is time to take corrective action. However, some of the newer project methodologies can be challenging as it is harder to define controls. Read the following paper. Tilk D. 2016. Five Steps to Agile Project Success. The dynamic, fast paced nature of Agile software development requires auditors to think differently about internal controls. Internal Auditor 2 P57 Academic 1 file EBSCO host available at https://search.ebscohost.com login.aspx direct equals true and db equals edsgao and an equals edsgcl dot 45069 5664 and sit last access on the 13th of July 2017. As traditional controls may not be relevant, make notes on how to keep control of a project using agile or incremental methodology. Make a note. Describe in detail a methodology you have used on a project. Draw a diagram to help your explanation. Address the stages in the life cycle, identifying the main activities at each stage. Critically assess if the methodology aids management control of the project. Describe which types of projects the methodology is suited to and explain why. Identify any disadvantages of the methodology. If you have not used a project methodology, research one that is suitable for the type of projects you aspire to undertake in healthcare. A methodology described in this lesson may be used, but you are required to provide more detail in the context of your project. If you are currently working, you may find it useful to talk to your management or experienced project managers at your workplace. Moving forward. Now that you have completed this lesson, reflect on what worked well and what would be done better in your next lesson. Let's move this forward. Consider again the diversity of projects in healthcare, from public sector projects to social care projects to technology projects. Reflect on why project management facilitates the management of such diverse projects. Make a note. Recall what you have learned. A mind map may help you. How you have interacted with the activities, what you have gained by interacting with the colleagues through the discussion forum, and in what ways you have developed your communication skills. Record what worked well and what you could do better next time, e.g., more independent learning. Check your understanding of the learning outcomes relating to this lesson. Consider how your learning experience from this lesson will influence your approach on the next lesson. Reflect on the development of the graduate attribute, knowledge and understanding of project management in healthcare. Possesses a range of skills to operate in this sector. Have a keen awareness of current developments in working practice, being well positioned to respond to change. What practical steps have you taken towards achieving this? How will this influence your approach in the next lesson? Key text and additional reading. Your key text is Wazowski R. Edited 2014. Effective Project Management, Traditional Agile Extreme, 7th edition. Iandonopolis, Wiley, available on EBSCO. Read Chapter 12, which complements this lesson and compares various methodologies. You are also strongly advised to undertake some additional reading from the following list books. Martin V. et al. 2010, Managing in Health and Social Care, 2nd edition Routledge. Mailer H. 2010, Project Management, London, Pearson. Myrna T. and Faisal F. 2008, Cooperative Risk Management, 2nd edition, London, Wiley. Slapper G. and Kelly D. 2013, The English Legal System, 13th edition, London, Routledge, Arden, EBSCO. Additional reading is available through Arden EBSCO registration. You are advised to locate some papers of relevance to the material covered and your organizational industry context, journals, project management journal, Journal of Modern Project Management, Journal of Risk and Uncertainty, International Journal of Healthcare Management websites, https://www.pmi.org https://www.amnet.org/https/www.networks.nhs.uk/nhs networks nwas library and information service guides. References: PMBOK Handbook 2013, A Guide to the Project Management Body of Knowledge, 5th edition, Project Management Institute. Murphy P. 1989, Pharmaceutical Project Management. Is it different? Project Management Journal 23, 35 to 38. https://search ebscohost.com/login.aspx direct equals true and dp equals edsgao and an equals edsgcl.497508220 and sit https://search.ebscohost.com/login.aspx direct equals true and db equals edsgao and an equals edsgcl dot 450695664 and cit Now return to the module home and complete the end of lesson activity. And that is the end of the lesson, second lesson. I hope you enjoyed the lesson. The next lesson is going to be lesson 3, which is going to be selecting and initiating projects. That's selecting and initiating projects. I look forward to seeing you then. I hope you enjoyed the lesson. Until our next encounter, please feel free if you have any comments or you would like to leave any notes or any positive feedback, or anything like that on the post below, and I will try to get back to you about that as soon as possible. Until then, it's Abdurrahman here saying have a lovely afternoon. Bye.